Welcome to the video of our paper titled How Well Do Feature Visualizations Support Causal Understanding of CNN Activations? This was a joint project with all these great people, and Roland and I are happy to present our findings to you today. As a heads up, you can check out our project website following the link at the top right. Feature visualizations are a popular explanation method for CNNs. To produce feature visualizations, you start out with, for example, a random noise image, and then iteratively leverage gradient ascent to maximize the network's activation. Some of these synthetic visualizations, like this one here, show quite interpretable structures. In fact, feature visualizations are believed to isolate and highlight exactly those features that cause a unit's response. As shown with these two example visualizations, they can help distinguish whether a unit responds to a whole dog's face or just an eye. In this project, we therefore test this intuition and want to learn how well feature visualizations support causal understanding of CNN activations. Our assumption is that if these synthetic visualizations indeed grant more causal insight, then they should allow humans to predict the effect of an intervention better. Specifically, we asked participants in an online crowdsourced experiment about the causal relation between manipulated images and a unit's activation. Here is what one of the trials looked like. For a certain network unit, participants see several strongly activating feature visualizations. On the right-hand side, they see yet another strongly activating image, this time though, a natural one. Below this natural image, two copies with square occlusions at different locations are shown. The question is, which of these two manipulated images elicits a higher activation? When we break this task down, what we're really asking is which of these images here contains as much content as possible of whatever seems important for a specific unit based on these reference images here. In order to set participant accuracy into context besides the chance level of 50%, which a random guesser would achieve, we test other conditions. As an example, this is the natural condition, where we show natural data set samples from ImageNet as reference images.
Let's now look at our results. Our main finding is that feature visualizations do not support causal understanding particularly well. To see this, we'll take a look at our data. On the x-axis, we plot the different reference image conditions. In the two example trials before, you just saw the synthetic visualizations and natural dataset examples. On the y-axis, we plot the participants' accuracy. For your orientation, chance level is at 50% because of the two options in the forced choice task design. We first find that for the synthetic feature visualizations, performance was at 67%, which is clearly above chance level and hence means that feature visualizations do provide helpful information about the most important image patch. However, comparing this to the condition where no reference images are given and participants make their choices purely based on the free query images, it becomes clear that the advantage feature visualizations provide is rather small. Finally, we tested a few other visualization methods, such as natural dataset examples, and find their performance to be similarly high as that of feature visualizations. This is why we concluded that feature visualizations do not provide causal understanding particularly well. As performances between conditions are so similar, we thoroughly investigated whether participants actually really tried their best. The good news is, we are confident that this is the case. Here are the 5 reasons why. First, measurements of Julie and me are so similar to those of online participants, as you can see here in the light bars. For the other 4 reasons, the supporting plots can be found in the appendix of our submission. Second, the reaction times are reasonably long and vary across different conditions. In addition, for a few feature maps, there are large performance differences between no visualizations and some visualization methods. Further, in an optional free text field, comments of online participants such as "I did my best" indicate that they're really engaged in the task. Finally, the trial-by-trial response patterns were more familiar than expected by chance. In summary, we showed that the widely used visualization method by Ola et al. Does not convey causal understanding of CNN activations as well as previously thought. This exemplifies how important it is to test falsifiable hypotheses in the field of XAI. It is out of doubt that feature visualizations have an important place within the field of interpretability, and that with more and more societal applications of machine learning, this method will become even more important. However, we want to conclude by saying that clarifying what we can and what we cannot understand from an explanation method will be a crucial part in the future. Specifically, we hope that our task will serve as a challenging test case to steer further development of visualization methods. Thanks for watching this video. We look forward to discussing our work with you. You can find more details as well as a link to our archive submission and a project website following the link at the bottom of the slide.